close, man. Oh, it's really cool.
One clicker spring.
Oh god, it's at 57.9. Whoa.
Dude, what are you doing?
I'm trying to, well, there's a thing called, supercooling, which is when you, lower the temperature of something, like a liquid, or a solid, below its, freezing temperature. Yeah, liquid. Below its freezing temperature, but it doesn't actually freeze. And you can do that because in order for something to, freeze, the molecules in it have to, like, line up in a certain way. And the way they do that is either, there's an impurity in the liquid for them to latch onto, or, well, not latch, but yeah, or like they're knocked into place physically, like you whack them. And but if you use like distilled water, so like pure water, so like you could use like Fuji, you can do this at home. And if you freeze it below its freezing temperature, it can still not be frozen because there's nothing for it to latch onto. And you can whack it and it'll all freeze, or you can pour it out and it'll freeze. So and the thing is, but when it crystallizes after the supercooling, they release a lot of heat. So that can like in large amounts that could be very interesting and like an industrial way, so like harnessing it in like factories.
Oh, so you're testing how much heat comes out?
No, so we're testing adding water. It like can either slow it. We're not sure if it slows it. Well, adding water to this different chemical. We're not sure if it slows it or speeds it down. But either way, there will be like pretty solid effects if it's speeded up or slowed down.
Oh, that's so interesting.
It is interesting. I'm glad you think so.
Started in your career? How did you do it?
Well, I had an idea, but then I wanted to work with Benjamin. Benjamin wanted to work with me, but he was set on his idea, and he's like, supercooling is really cool. Let's figure out more about supercooling and see if there's something we can do with that. And we figured out it was like interesting on a industrial level, so we went with that.
They originally wanted to do it with xylitol.
We did.
Xylitol doesn't like melt till what, 150?
Yeah, it was crazy.
Ridiculously high.
And this is like, this one has a, it melts at 57. Oh, it's at 56.9, and it is still liquid. Dang.
You're going to want to double check that I'm putting these back into like gridding arrangement, and they have got some big fat ones.
Mr. Wick, in a couple minutes, I might ask you to either introduce the seed crystal or hold the camera and just,
Sure.
Yeah.
Samantha, do you want to take a turn tripping? Okay. Let me show you how I do one. Let me lift up one at a time. This has some mildly toxic stuff in it, so don't drink it. So you can see all these little lively dudes. Right there with the kind of dead compared to the others. So I'm going to pick that one up and discard it. So I don't have to keep like dodging it later. Alright, well these other ones are definitely live. We've got plenty. We've probably got 500 right now, and we only need like 100 over there. So I go 1, 2, 3. Okay, so there's 3. So I'm just pressing the bulb and then drawing them in, and then squirting them out of there. 4, 5, 6, 7, 8, 9, 10.
Looks like we super cooled this.
And,
Dang.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I'm trying not to introduce too much extra water. back to you? That one? Yeah, there you go. It was just, okay, so there's one. And yeah, you don't want to do like a whole huge slurp for just one dude, because the more you put in here, the more you're altering the concentration of the stuff that you've already got in there. It's inevitable to get some liquid from here into there. We're just going to try not to do huge amounts. Yep, right. Yeah, when you've got lots of extra fluid in here and there's not enough anywhere in it, you can put a few drops in there. And this gets a sticky note on it because it's been shrimped. And very carefully to not spill.
Mr. Wiggins, that
And her grid, the way her grid is set up, she actually wants to try and preserve that organization so that everything's in like an orderly fashion. So, you want me to watch you do a bit, or do you want to have her watch you do a bit, or do you feel like you're good? Okay. Yeah, you got one?
Mr. Wiggins.
Two in there?
Sorry,
Just a
sorry.
second, George.
Yes, sir.
How do you know it's gonna be really hard at first?
Mm-hmm. That's okay. I think that there's definitely going to be some water going in. And okay, notice that when you do it on an angle like that, they tend to get stranded on the sides. One of your dudes was stuck on the wall. So if you do it vertically, they're more likely to come out. And just putting some fluid in is a necessary consequence. We just try not to wheel it. There's your first 2 shrimp looped. 8 more to go. You got the idea?
So, Mr. Wiggins, it's at 55.4. I think that is pretty solid. I
Okay.
think it's super cool.
So I will hold your camera.
Awesome. So make sure you have both a pretty good view of this, but also have the temperature in there. Well,
Okay.
right now it's kind of not really needed, I guess. 'Cause
Yep.
It's been super cold.
So how long am I holding this for?
Just until I put both of the seed crystals in.
Okay. And it is recording, right?
Yeah.
Okay.
As long as you see that little time moving, we're good.
I don't see time moving, but I do see a red square. Oh, okay, there it is. It was lost in there.
Yeah.
It's white, and so when I had it down on the white
Oh, okay.
background. Okay, you're at 55.1.
Oh, would you say?
55.2 now, I think.
Actually, I haven't introduced the seed crystal. Would you say this is large enough?
It doesn't matter how big it is.
Okay,
It
awesome.
literally doesn't matter.
Both at the same time? It doesn't really matter.
Not one at a time is what I would do.
Woo! And does it have to be like actually a chunk, or can it just be?
It really shouldn't. A tiny crystal should be enough. I'm not seeing anything behaving, are you?
No, but it's supposed to take a couple minutes.
Okay.
I don't worry too much.
Then I will let you resume holding your camera.
Awesome, thank you.
You're most welcome, sir. And I'll jigger that so it...
Doesn't really matter. I don't think I need to get the temperature anymore, do I?
Well, it might be interesting to observe the amount of temperature climb. There might be some and there might not. Anyway, so you've got seed crystals in there of the sodium acetate trihydrate, right?
Yeah, I haven't seen anything. It took like, when we super crystallized it oh, I think I might see something on the bottom that appears what it looked like last year. It almost looks like last time. It kind of looks like webs. Because we did, well, we don't know if it was super cool, but it did crystallize.
Okay, cool. And how long did it take for the crystallization to climb up?
3-4 minutes.
Okay. If you want an actual rate in centimeters per second, you need a ruler in your frame at the same distance, right?
Oh, I should. Why
The same
not?
depth. It doesn't have to stay in the frame, but remember how you need a ruler.
At least for.
scale?
Can you hold that there for just like a second?
Yep. I'm not. I think this one's in inches. So I'll put it in case inches are better than nothing.
So, and is that enough? Yeah, because I can just draw a line.
Yep.
Right? Yeah.
Yeah, and so you could do like from 0 to 5 inches, and then tell the computer that that's something like 10 or 12 centimeters or whatever it works out to in the metric system.
Awesome. Thank you.
How do you think I should go about counting the brine shrimp?
Just a second. I'm trying to remember how to store this properly, and then I will come help you. This seems unstable. Yes, ma'am. What's your
I
question?
think I should count the brine shrimp without really expect.
In those beakers?
Yeah.
I would.
I could just end the experiment right now.
Yeah, but but I would wait at least 48 or 96 hours before ending the experiment. Because like you said, you think it's probably not a strong trend yet, right? Okay. So, you could find one big, well, yeah. Let's see if I can count my fingers here.
I think these P2 images are going to make a sense.
I think so. Honestly, Lyndon, I think, at least for the ones that aren't too black, too many black dots, if you just concentrate for a while and use these little glasses of mine, you can count them all. I can give you, a flashlight to help add more light to the situation.
Oh dang, it's crystallizing. Woohoo!
And what happens if there is no track?
Then you say, when you deliver your thing, that possibly the concentrations were too low, possibly the times weren't long enough, or possibly this material just isn't dangerous to this particular organism. Or, yeah. But I mean, just visibly, this is crappy water. Nobody would drink that, right? And that's a lot of contamination just from a visual basis of the environment. If somebody's dumping tons of nanotubes into a moderate-sized, a medium, a smallish lake, it would still be less polluted than that. And the brine shrimp are loving it. So you could say at least this organism, for at least the time scale was measured, doesn't seem to be negatively impacted.
It's gonna take a while.
Yep. So Lyndon, did you have a plan to feed your shrimp today?
Because I didn't.
Okay. Let me know if you want to borrow these glasses. They really are good magnifiers. Samantha, you feel like you're doing good? Do you need to set a timer so you can make sure to keep paying attention to your own experiment?
I waited for the
Okay. So right now, your temperature is... Oh, I can't check it. Okay.
Yeah. It's not that it's not crystallizing, it is. Like, it'd be super cool that we introduced that kind of pulse. And you can see it at the bottom, do you see that?
Yep, I do see it at the bottom. It's slower than I would have expected, though.
Yeah, which is what we wanted, frankly. I mean...
That's true. That'll give you hopefully a measurable difference.
Yeah.
Awesome.
Awesome.
So I'm going to see if there's a different temperature up high.
.1.
Okay. Doesn't seem like there's a big difference from place to place within your sample. Just for fun, I'm going to see how long it takes to measure. Oh yeah, look at that temperature plunge when I take it out of the water. So your temperature gauge is fairly responsive, and that means your temperature is pretty homogeneous from up here
It's awesome.
to down there.
Mm-hmm.
It's possible that this stuff is warmer than the water bath, but probably not crazy
Yeah,
warmer.
because it looks like it's crystallizing.
Yep. Well, but what I'm saying is, if the sodium acetate was at 60 degrees and the water outside of it was at 51, that would explain it crystallizing really slowly.
Yeah.
But I think just continuing to circulate the water.
And now we don't
With
have
a
to worry
skinny
about...
little test tube like that with lots of surface area, your water and your acetate should probably be at fairly close temperatures.
Wait, so real quick.
Mm-hmm.
Does banging it around still matter? Because would that speed up the crystallization?
I don't think we're banging it around. And if that was causing it, then what would you start to see is another crystal forming like on the walls or at the surface rather than this one growing. I guarantee that banging won't much affect the crystal growth rate down here where the solid is.
Okay.
Yeah, so for your next one, let's definitely get the automatic stirrer going so that that's one less thing to worry about.
And that just circulates the water?
It just circulates the water, yeah.
Wait, so real quick, just physics question. This is totally unrelated. Using a hot plate. So, we're taught that since heat expands.
No.
Well, heat heat rises. I know that's not. I know. But
the material that is hot often expand.
So,
in the case of
what's
water,
hotter,
there's
the top of the water or the bottom of the water? Because the bottom's being heated, but...
Fair question. I think the bottom and the top are hottest, with cool in between.
Okay.
Because the bottom is hottest because it's touching the water, and then chunks of water that are warmer will expand very, 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 very slightly and rise. In air, the effect is really dramatic because heated air expands a lot. Heated water expands just so barely, minimally at all.
Really?
Yeah.
Wait, so now I'm kind of getting worried about time. What would you say, how much, I have to leave by 5:30. What would you say, how much time I should, like, allow myself for cleanup? Like, 15 minutes?
10 or 15, yep.
Okay, now I'm getting a little worried. Whatever.
What temperature are you trying to get to? 5? Okay. You still got plenty of ice down there, right?
I've done all 3 trials now of the solar water. And if I have to do the solar freshwater water, I was first going to do just 1 trial of each just
Okay.
if I had time,
Okay.
actually,
So you don't need this at all? What kind of water is it in there? And you already did distilled ones at 5-degree temperature? Okay.
It was also the one that when I put it in, it just sort of stayed in the same place.
Got it.
Put in the oil harder, which is the open.
Right. Okay.
It got bigger.
So let me know when you want me to come watch with you, and I'm happy to do that. The other thing you can do to slightly speed up the cooling process is stir this stuff. Because it's possible that this narrow sleeve of water around your
Whoa!
it's possible that narrow sleeve has gotten kind of warm, and so I'm doing this to make sure that it circulates and the icy stuff is surrounding your inner bath. What are you worrying about?
Look at that. It just popped out of nowhere.
Did it really?
Yeah. Like, I literally was, like, looking at the screen and I looked. I was like, whoa. Wait, so... See that right there? See, it's crystallizing.
Oh, whoa.
It's pretty damn cool. Damn, that's frozen stuff. It's gonna take so long. I really hope I...
Oh, you only need
down time.
Yeah.
It's been like 9 minutes and it's moved that. It's frozen that much.
Okay.
Is it supposed to get
Right.
all the way up to here?
Correct.
Well, it's
So
not
this
supposed to.
thing
We were trying to
only
slow it down. I
activates
guess we didn't
down
know
to
it was
the
going to slow down this much.
emails or something like that. So what you can do is get a pipette, fill this up to like 20, and how many mils do you need? 2? Then just suck it down until you're at 18.
So for all the ones I did that, should I just go to my search to do another job? Because I can't.
It's up to you. Yeah, it's up to you. Just bearing in mind that it's 5 o'clock and,
Oh, dang, there's another one.
I might not leave at the exact ticket of 5:30, but that's the time I promised to be here until, and I don't want to stay tons and tons of time after that. Which of these, if any, Lyndon, are you suspicious of and thinking that you might remix?
I need the ones that have carbon energy 25 more.
Okay, point.
So,
So these are the ones that you might leave. I gotta tell you, that doesn't make tons of sense to me, Lyndon. Because you're using a 2 milligram aliquot of the CNT mix.
no, I'm using 2 milligrams of water.
2 milliliters.
Because it adds
Okay.
versus 24.
Got it. So what I would do in the future is put CNT solution into the graduated cylinder and then add liquid ocean, instant ocean, until it gets to your full 20 or 25 amount.
Mr. Rick, just so you know, I'm taking the temperature out of the picture right now. Do you think that's
Whatever.
okay?
It's up to you.
Yeah, I don't think it's really necessary
I
anymore.
know how your arms could get tired just holding that thing all the time.
You have no idea.
So,
Wait.
so
Second.
okay. So Lyndon, are you encountering the same problem with your small dilutions? Just in the opposite direction because you only need...
The problem is not in these ones. It's just small.
Okay.
Samantha, can I ask you a huge favor real quick? Can you hold this like at like this just for a second while I get some more weight?
Yeah.
Thank you.
Alright, well, I'm gonna keep shrimping while and I'll just shrimp those ones last that you're suspicious about.
Okay, let's see. Awesome. Thank you, Samantha. It is frozen now a significant amount. Dang, this is pretty cool.
Cool.
Oh, do you think, like, worst comes to worst, if it doesn't go up all the way, I can still measure the rate of the crystallization?
Yep.
From, oh, that's perfect. This is so cool.
I'm out of sticky notes, so I'm just gonna use masking tape. That's it. Oh, cool. Thanks. Yeah, can you give me about 7? Thank you.
Well, I'm done with the last one, so. I use them after I'm gonna count the bond.
I don't know what to tell you.
This is so cool, actually. Wow. That's really satisfying to, like, work on something for a while and just have it actually work.
If I want to
A second, please. I think so. There's 1 or 2. It's 2. Okay, go ahead.
is frozen small.
Mm-hmm.
Do you think are they also body trapped? What should I do?
Both push.
Think?
Push.
Bushwick.
Who?
I'm just checking on the.
Tryouts?
Yeah.
BSRP was going like kind of haltingly, but I've just had crap load of progress. You can come see right now. What are you doing?
We're doing trial.
What's that you doing?
That's me and Patty.
Oh, who else is in there? On what? On grinder?
It's a trap. Yeah. What time is this program? What a time. Basically, they're like small crustaceans. Oh, you know those? They're like, they're really you know,
Like,
Yeah,
you
what
ones
am I
that are
saying?
like
What am I
like
saying?
sandal crafts and stuff?
Yeah.
Horses crafts. Yeah. Do you going your finger? What's the difference between what's the difference between a bus station hood and a polo with breath? One of them's a
George, this is gonna be offensive. I'm just gonna go ahead and say, tell that joke later.
Oh, it's actually the fun.
I'm coming. I'm just cleaning up. Yeah, I'll be down there in like 5 minutes.
yeah. They get bigger.
Well, we're not.
They won't, they would.
Well, yeah, I know some of
At that point,
apparently it doesn't even sound human growth.